EM wave equation in good conductor in electric field and magnetic field.
Good evening to all. Today I discuss about EM wave characteristics from Unit 3 EMTL subject. What is EM wave? An electromagnetic wave is self-propagating wave. Is made of oscillating electric field and magnetic field also perpendicular to each other. Then the magnetic wave. The wave is propagating in light. That C equals to 3 into 10 power of 8 meter per second. Then the electromagnetic waves are used in radio waves, light waves, TV signals, radar beams. Now I discuss about the topic is EM. EM wave characteristics. The extension of EM wave characteristics predicted by Maxwell's equations. There are 4 types of propagating wave. First one is free space. Second one is lossy dielectric. And third one is conducting medium. And fourth one is perfect dielectric. In free space, the sigma value is 0, where epsilon value is epsilon naught and mu equals to mu naught. And lossy dielectric, where the conductivity is not equal to 0 because it is a good conductor. Then epsilon equals to epsilon naught into epsilon r and mu equals to mu naught into mu r. And also the conducting medium, the sigma equals to infinity, epsilon equals to epsilon naught and mu equals to mu naught into mu r. Then perfect dielectric, the sigma equals to 0, epsilon equals to epsilon naught into epsilon r and mu equals to mu naught into mu r. Before the start the topic, we know the some basics. First one is mu naught. Mu naught is permeability of free space in magnetic field. Then the mu naught value is 4 pi into 10 power of minus 7 Henry per meter. And epsilon naught is permeability of free space in electric field. Then value is 8.854 into 10 power of minus 4 farad per meter. What about the magnetic flux density B equals to mu H? The electric flux density D equals to epsilon into E.
I discuss about the equation for EM wave in good conductor in electric field and also to find out the magnetic field also. First of all, we discuss about the electric field from Faraday's law. The del cross E equals to minus dou B by dou T. Then we apply the curl on both sides. Then del into del cross E equals to minus dou into del into B by dt. Then apply the theorem where del into del cross E minus del square E equals to minus dou del into B by dou T, where the divergence of vector electric field E bar is scalar. If that represents the net of outflow, then we can del E bar is also 0. Then we remains the del square E equals to minus dou by dou T into del cross B. Where what about the B value? Last class we discussed about mu H. Then we can write del square E equals to minus dou by dou T into del into mu H. Then we can write del square E equals to minus dou by dou T and mu into del into H. Then we can write where del cross H from Ampere's circuit law. So The Ampere circuit law is del cross H equals to JC plus JD. The JC is conducting current and JD is displacement current density. So dou D by dou T. Then now with the del cross H equation 2 in the substituting equation 1,
2 in 1, where minus del square E equals to minus mu dou by dou T into sigma E plus dou D by dou T. Then minus del square E equals to minus mu dou by dou T sigma E plus dou D by dou T. Now minus del square E equals to minus mu dou by dou T sigma E plus again multiply the minus mu dou by dou T into dou D by dou T. We cancel the minus. Then we can write del square E equals to mu by dou T sigma E plus mu by dou square by dou T square into D. What about D? D equals to epsilon into E. Then we can write del square E equals to mu by dou T sigma E plus mu epsilon dou square E by dou T square. Then the harmonic time equation field, time varying field, the vector field that oscillates sinusoidally over the time, where d by dt equals to j omega. Then del square E equals to mu into d by dt j omega sigma E plus mu into epsilon d by dt j square omega square E, where j square equals to minus 1. Then del square E equals to mu j omega sigma E plus mu epsilon minus 1 into omega square E, where the del square E equals to mu j omega sigma E minus mu epsilon omega square E, where del square E minus mu j omega sigma E plus mu epsilon omega square E equals to 0, where gamma equals to j omega mu root over sigma plus j omega epsilon. Then we can write gamma square equals to j omega mu into sigma plus j omega epsilon, where del square E minus j omega mu common. Then we can write sigma plus j omega epsilon into E. Now we can substitute the value j omega mu into sigma plus j omega E. Then we can write sigma E minus gamma square E equals to 0. That is the electric field in EM wave equation for good conductor. In magnetic field, we can take Ampere circuit law, where del cross H equals to JC plus JD. Then apply the curl on both sides, where del cross into del cross H equals to sigma E plus dou D by dou T. Then apply curl del into del cross H equals to sigma del into E plus dou by dou T del into D. Then we apply the theorem, where del into del H minus del square H equals to sigma E. What about del cross E equals to minus dou B by dou T plus d by dt. Then again malla where del into d means what about d equals to epsilon into E. Then where del H is divergency is 0. Then we can write del square H equals to sigma minus dou B by dou T plus dou by dou T. Epsilon will be common where del cross E. Now again where del square H equals to minus sigma dou B by dou T plus epsilon dou by dou T, where again del cross E equals to minus dou B by dou T. Now we can write minus del square H equals to minus sigma dou B by dou T minus epsilon dou square B by dou T square. Then the minus will be common. We can take minus will be common where sigma dou B by dou T plus epsilon dou square B by dou T square. The minus will be cancelled where del square H equals to sigma dou B by dou T plus epsilon dou square B by dou T square. Then the del square H equals to sigma dou B by dou T plus epsilon dou square B by dou T square, where B equals to mu H. Then we can write where del square H equals to sigma mu into dou H by dou T plus epsilon mu into dou square dt square into H. Now where time varying harmonic equation, then d by dt equals to j omega, where del square H equals to sigma j omega mu H plus epsilon mu into j square omega square into H, because the derivative d by dt square equals to j square into omega square, where j square equals to minus 1. Then the del square H equals to sigma j omega mu H plus epsilon mu into minus 1 omega square H, where del square H equals to j omega mu will be common. Then we can write sigma plus j omega epsilon into H equals to 0. Then del square H equals to gamma H minus gamma square H equals to 0, because gamma equals to root over j omega mu into sigma plus j omega epsilon. Then gamma square equals to j omega mu into sigma plus j omega epsilon. Then we can write the del square H equals to H minus gamma square H equals to 0. It is the magnetic field in good conductor.